Question number 4. Write the following sets in set builder form, means rule method. Okay. Let's go for first sub question. So first sub question 3, 6, 9, 12. Okay, this is the given set. Let me give a name for the set. I'll call it A. A is equal to 3, 6, 9 and 12. So obviously this is in rule method because the list of all the elements is given. So this is in the roster method, sorry, this is in the roster method. So we have to write this in rule method. So the list is given. What about these numbers? 3, 6, 9, 12. Have we seen them somewhere? Yes. Multiples of 3, right? So I can write these numbers in the form of 3 into 1, 6 can be written as 3 into 2, 9 can be written as 3 into 3, 12 can be written as 3 into 4. So all these numbers can be written as 3 into something. So in a general form, if I write, all of these look like 3 into something. I'll call it as some n. I'm replacing these numbers which change with the letter n. So 3 is everywhere constant, isn't it? 3, 3, 3, 3. 3 is constant, but these numbers change. I'll call them as n. What about the values of n? Can they be any number? No, they are strictly 1, 2, 3, 4. 1, 2, 3, 4. Where have you seen those numbers? Natural numbers, right? They are all natural numbers starting from 1, and natural numbers do not have any end. They go on till infinity. So we have those natural numbers which are lesser than or equal to 4. We have 1, 2, 3, 4 which are lesser or equal to 4, or you can strictly say that they are all lesser than 5. See, 4 is lesser than 5, 3 is lesser than 5, 2 is lesser than 5, 1 is lesser than 5. So you can say and n should be lesser than 5, strictly lesser than 5, and at the same time n should be a natural number. So you can say n epsilon, which means belongs to natural numbers, right? So do you understand this? What is it given? 3n, any number which looks in the form of 3 into something, where that something should be strictly lesser than 5 and a natural number. If you look at all these conditions, only these numbers will satisfy the condition. Any other number you take from outside will not satisfy. Example, sir, if n is 6, so 3 into 6 is 18, right? Does it belong to this A? No. Why? It does not agree with this condition, that is n is lesser than 5. 6 is not lesser than 5, but yes, it is a natural number, but it is not lesser than 5. So then that element does not belong to this set. Only those elements who are in the form of 3 into something, according to Euclid's lemma, 3 into something, if you can write it without reminder, means it is a multiple of 3. So this is 3 into n means multiple of 3, where n value should be less than 5. Also n should be equal to n. This also can be written as n less than or equal to 4. Instead of strictly lesser than 5, you can write n less than or equal to 4. Meaning is same. Here the values can be 1, 2, 3. Since equal to 4 is there, you can add 4 also. So similarly here, can you write 5? No, because strictly lesser than, not equal to. So again the answers will be 1, 2, 3, 4. So if you want values from 1 to 4, you can either write less than or equal to 4, or you can write less than, strictly less than 5. So now using all these ideas, how to write the set A in rule method or set builder form. A is equal to set of all x such that, I hope you remember this much from the theory part. Remember, A is a set of all x such that x is, or x is equal to, when we say in sentence, it is x is a number, okay? X is a number which can be written in the form 3 into something, means multiple of 3. There is no reminder here extra. If I write plus 1 or plus 2, then remainder is there. If remainder is there, then it is not a multiple of 3. Here no remainder, right? So that means it is a multiple of 3, and n should be strictly lesser than 5, or you can also write less than or equal to 4, and n belongs to natural numbers. Now that is the set builder form for 3, 6, 9, 12. Here you go. Second sub question. A set with elements 2, 4, 8, 16, 32. Now let us call it with a name. I'll call it as B. You can give any capital letter from the alphabet. So 2, 4, 8, 16, 32. I repeated that. Now let us have a look at the numbers. They suddenly first and second, if you see, it's like again the previous problem, like 2 ones are 2 twos are 4, but 2 threes are 6. Multiple of 2 is not given. If it was multiple of 2, 2, 4, 6, 8 it should have been there. 6 is not there. So it is not multiple of 2. What else? Please have a look at those numbers. They are all products of 2, but with 2 itself, they are all powers of 2. Can you make out? See here. First one is 2 to the power 1. Second one is 2 squared, 2 cubed, 2 raised to the power 4. 32 is again 2 into 2 into 2 into 2 into 2. That is 2 to the power 5. Right? 2, 2 into 2, 2 into 2 into 2, 2 into 2 into 2 into 2, 2 into 2 into 2 into 2 into 2. Right? 5 of them. So what's common in everything? The base in the index form, when you write, the base is constant here. So I can say x is that number which is of the form 2. The base is same. The index is changing. What are the indices? 1, 2, 3, 4, 5. Again natural numbers, right? I'll call this as power n. Why did I write n? Why did I not write the number? Because it's varying. Variable. See, the base is constant, it's 2, but the indices is varying, changing. So we use a variable. I can use x, y, but x is already written. You can use y, z, m, n, p, anything. So I used n. What about the speciality of those numbers? They are all natural numbers starting from 1, right? Natural numbers start from 1. But the last number is 5. The last number is 5. So it should be less than 6. Or less than or equal to 5, like the previous problem. So you can say n is either less than 6, true, or you can write n is less than or equal to 5. So here strictly less than 6 means all these numbers are strictly less than 6. Less than or equal to 5, because less than numbers also is there, equal to 5 is also there. One of these you can use, any one of these. And n belongs to natural numbers. Sorry, I have not yet written the set. So these are the conditions. Any other number cannot follow this condition. If any other number would have followed the condition, then I couldn't have written this as a property. This property only holds good for these 5 numbers. See, any one of them you change. For example, 2 to the power n plus 1 if you write, then you don't get this answer. Then n is less than 6 is there. If you write less than 10, then again different numbers would come. Other than these, more numbers would be added. If I don't write n belongs to natural numbers, if I take any other set, for example integers, I will be having more answers here. If I take real numbers, rational numbers, I will be getting innumerable answers. So this answer, or like this particular set of 5 elements would be only possible if you take all these 3 conditions. So now I can write B is a set of all x such that x is equal to, x can be written as 2 raised to n, where n is strictly lesser than 6, or you can write this one also. What is that? N is less than or equal to 5, and n is also a natural number, or n belongs to natural number. Hence, this is the set builder form for the given set. Third sub question. The set contains 5, 25, 125 and 625. Let us first of all name the set. Okay, C is equal to 5, 25, 125, 625. If you have done the previous problem, this is very similar to that. These are just powers of 5. So if I just write it in that form, it's 5 to the power 1, 25 is 5 square or 5 fives are, 125 is 5 cube and 625 is 5 raised to power 4. Those who got the gist of the problem, those who got the clue from this, try to complete it even before the video completes. Look at the problem, previous problem, and try to solve it. You can pause the video and check those, and then you can continue the video to check your answer. Okay, let's continue now. So I can call, if x is the element which belongs to C, then it should be of the form. What is constant? The base, that is 5. What about the power? It's changing. So if anything is changing, I'll take a variable. I take n here because it's a natural number. You can take any other variable, You can take any other variable. So what about this n? They are 1, 2, 3, 4, means lesser than 5. Strictly lesser than 5 or less than or equal to 4. Now, so n being strictly lesser than 5 and n must belong to natural number. These are the 3 conditions that these numbers will have to follow. Here you can change it as, of course, n less than or equal to 4. Now, how to write it in the represented form? C is a set of all x such that x can be written as 5 to the power n, where n is lesser than 5 and n belongs to natural numbers. Flower bracket or braces closed. That is the answer. Sub question number 4. The elements of the set are given as 2, 4, 6, so on. Means it's not ending, it's continuing without end. In that case, let us have a look at the numbers. First of all, let's name the set. Call this as D, which is equal to 2, 4, 6, so on. Right? Now that is the roster form or the list method. Now let us try to understand the properties of the elements. The elements all are multiples of 2. So obviously first one is 2 ones are, second one is 2 twos are, third one is 2 threes are, and so on. But where is the ending term? We don't know. It just continues. So what can you say about all the elements? I'll call them x. X is equal to, what is same? 2 is same in everything. So it must be 2 into. What about the next terms next to 2? They are variables. They are changing. 1, 2, 3, 4, 5, so on. So you can say that next number is n. You can either write as 2 into n or 2n. Both are same. 2 into n is 2n. Right? Okay, I'll write it here. 2 into n, which is 2n. What about n? See, n values are 1, 2, 3, 4, 5, 6, 7, 8, 9, never ending, goes on like that. Remember which numbers? Natural numbers, of course. Natural numbers. What is set of natural numbers? All numbers starting from 1, counting numbers. Starting from 1, 2, 3, goes on without end. So, you can directly say n belongs to natural numbers. Here I am not adding any limits for that, like it should be lesser than this or greater than, no constraints for that. Fully free. N can be any natural number starting from 1, 2, 3 and continuing without end. So just 2 conditions. What is that? It should be written as in the form 2 into n without any remainder, no reminders, and n is always a natural number. How to put it in set builder form? D is a set of all x such that, okay, x can be written as 2 into n and n belongs to natural numbers. Sub question number 5. The numbers or the elements of the set are 1, 4, 9, so on till 100. Okay. So you know the numbers, right? 1, 4, 9. Have you seen those numbers? Perfect squares, of course. They are perfect squares. So 1 is nothing but, okay, let me name the set first. I'll call it as E. Set E is equal to 1, 4, 9, go on till 100. Now, what is 1? 1 is 1 square. What is 4? 4 is nothing but 2 square. Perfect square, right? 9 is a square, which is nothing but 3 square. You can guess the next ones actually. 4 square, 5 square, like that. It continues till 100. What is 100? It is 10 square. So this time, look at the base. We have written again in the index form, but look at the base. Base is changing. Base is the variable. What is constant? The power or the index is the constant. So this time, if I write all the elements as x, then x is of the form, see, the base is changing, but the index is constant. What is the index constant? 2. That is the constant index, right? What about this place? It is changing. So I will use variable. I can use n or y or z, m, anything, a, b, c. Okay. So n. What about the n values? N values are all natural numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All are natural numbers. So yes, n is natural number. Further, do you use all natural numbers till infinity? No, only till 10. So strictly less than 11. I can say n is strictly less than 11. Or you can say n is less than or equal to 10. Any one of these. Both mean same. Both mean same. So natural numbers less than 11, strictly less than 11, or natural numbers less than or equal to 10. We'll give you the answer 1 to 10 here. So how can you write in the rule method? E is a set of all x such that x can be written as some variable to the power 2, or any variable square. Also that variable should belong to n, or I can write it at the end. Now doesn't make any difference. The order is not important. N is strictly less than 11 and n also belongs to natural numbers. So that is the set builder form for the given set. Fifth main question, list all the elements of the given sets. Okay, yes, they are giving us sets and we have to list all the elements, means they are going to give us the property, means set builder form or the rule method. We are supposed to write the list of elements, means we should write the roster method, identifying the elements. Let us begin with sub question 1. Sub question 1 says A is a set of all x such that x is an odd natural number. So two things here, x should be natural, x should be odd. Don't get confused with both. Okay. So let us see what are natural numbers. Counting numbers 1, 2, 3, 4, 5, 6, so on till infinity is called as natural numbers. In that, pick only the odd ones. Which are the odd ones? Let us note A is equal to, odd starts from 1. 1 is odd number, 2 is not odd number, it's even. So next is 3, 5, 7, till where? They have not given the limit till where it is. So we just continue it. We write dot, dot, dot. 3 dots indicate continuous without end. So we can write A is equal to 1, 3, 5, 7, so on. So on, that's all. Till where? Don't know. That is first one. That is roster form. Sub question second says that B is a set of all x such that x is an integer. X is an integer. Pardon my handwriting there. Okay. And also x lies between minus half and 9 upon 2. So means minus half should be lesser than, strictly lesser than x, and x should be strictly lesser than 9 by 2. If you consider in decimals, it's easy to understand. Same things you can write it as minus half is nothing but minus 0.5 less than x less than 9 by 2 is 4.5. Now it's easy to identify the integers. Which are the integer values? These are not integer values. Which integer value comes after minus 0.5? It's not minus 1. Minus 1 is still lesser. So 0. Okay, that is 0. We start from 0 and till where should we continue? Less than 4.5. Greater than minus 0.5 is 0. So what about minus 1? It is smaller. It is smaller than 0.5. Right? See, if you look at the number line 0, 1, 2, 3, 4, so on. Integers on the other side minus 1, minus 2, minus 3, so on. Minus half, where will be minus half? Between 0 and minus 1, this is minus half. This point is minus half. It should be greater than that. X should lie on the right side of that. Means it should start from here. This side. It should be less than 4.5. So this is 4. I'll write one more number 5. Where is 4.5? Between these two. This is 4.5 plus 4.5. So your answer should lie between these two things. Between minus half and 9 by 2. Which are those integers? 0, 1, 2, 3, 4. That's all. So answer is, write down, set B is equal to 0, 1, 2, 3, 4. As simple as that. Sub question 3. C is equal to set of all x such that x is an integer and x square is lesser than or equal to 4. Not strictly lesser than 4, less than or equal to 4. Let us have a look at this. Integers means it's possible that x can be a positive or negative value. Why do I take negative value? Because when you square, the answer will be automatically positive. We are seeing here positive 4. So any number which gives positive 4 or less than positive 4 when it is squared, not the original one, only after you square it. So let us go to the roots first. Which all values can I take? Can I take 0? Let us try. If x is 0, then 0 square is 0. Is it less than or equal to 4? You have to check only this condition. Is the square. So yeah, I take x is equal to 0. I'll write it better. X equal to 0. We are talking about x. First value is 0. What is x square? 0 square is 0. Is 0 less than or equal to 4? Yes, it is strictly less than equal to 4. So 0 is a selected number. Okay, 0. I wrote it. I'll just write it here. C is equal to 1 member got 0. So what about 1 in the integer? 1. Okay, let us try that. X is equal to 1. So what is x square? 1, of course. Is 1 less than or equal to 4? Yes, it is lesser than 4. Then that proves x can be 0 and now x can be 1. So x1 also possibility. What about any other values of x? Like minus 1. Is it possible? Let us see. X equal to minus 1. So if x equal to minus 1, what is x square? Minus 1 into minus 1. Minus into minus plus 1 ones are 1. Answer is 1. X square is 1. Is 1 less than or equal to 4? Yes, 1 is lesser than 4. So this is true. So what did I take x value? X value is minus 1. Don't look at this squared term, okay? X should be written here. We are writing x such that its square should be less than 4. Its square is here. See, I'll write the number in a circle and the squared object in a square itself. So the number is this, the squared object is this. We have to check the squared object less than 4. Is the squared object less than or equal to 4? Yes. But writing will not be that, but x should be written. The circled thing, that is minus 1. So answer is minus 1. What is the next option after 1? 2. So take 2. So what about 2? Let x equal to 2. We want to find out x square. X square is 2 2s are 4. Is it less than or equal to 4? Surely it is not less, but it is equal. 4 is equal to 4. Then that is also true. So what is the value of x? Value of x is 2. Not this one, This is the square number. Look at x. X is 2. Last, if it is minus 2, let us try that also. X equal to minus 2. If x equal to minus 2, then x square is equal to minus 2 into minus 2. Minus into minus plus. 2 2s are 4. So, 4. Is 4 less than or equal to 4? Yes, it is equal to 4. That means it satisfies. That means x equal to minus 2 also is considered. What about next number 3? 3. If x is equal to 3, then x square is equal to 9. Surely that is not less than or equal to 4. 9 is not lesser or equal to 4. Means 3 cannot be taken. What about minus 3? It's a smaller number, right? Minus 3. If I take minus 3. Minus 3 square. This is x is minus 3. Squared. It is plus only. Because minus 3 into minus 3 is plus 9. Minus into minus plus 3 3s are 9. So again it will not be less than or equal to 4. Had it been minus 9, yes, it would be smaller. But we don't get minus when we square. We get plus number, positive. So minus 3 into minus 3, plus 9. Plus 9 not equal or less than 4. So we cannot write. The last is this. We stop at that. So final answer C in roster form can be written as, what is that? 0, 1, minus 1, 2, minus 2. That's it. Sub question number 4. Set D contains x or is set of all x such that x is a letter of the word loyal. So loyal is an English word. We have to only pick out the letters from that and write it specially. That's all. Simple. So D is equal to, only pick out the letters from loyal. First is L. Okay. L. O. Good. Y. Already written? No. So I can write it. Next is A. Is it written anywhere? A? No. L. Already written. I cannot repeat. And the order is not important. So that's it. L, O, Y, A. Another L is not written because we don't repeat the elements in a roster form in a set. Sub question 5 says that E is a set of all x such that x is a month of a year which which does not have 31 days, or it's not having 31 days. So let us look at all the months which do not have 31 days. Let's start. January has 31 days. So we can't. How do we do that? What is the trick? Okay, somewhat like using your knuckles, right? January 31, February not 31. So it is eligible, I suppose. February. I am writing only 3 letters, the shortcut. February. March. April. Yes. April has 30 days. It does not have 31 days. February had 29 days. Then comes January, February, March, April, May. May is 31 days. May, June, 30 days. June. Okay. What's left out? Only one single letter. Okay, anyhow, I'm writing everything in 3 letters. So, June. July. No. August. No, they are all 31. September, 30. Okay, September. September. October. November. Yes. So, if you look at all the letters, set E contains of all those months which do not have 31 days. 28 or 29 depending upon leap or not leap year. 30, 30, 30, 30. That's the answer. Sub question number 6 says that F is a set of all x such that x is a consonant in the English alphabet which precedes k. Precedes means before k. Okay, before. Succeeds means after k. Precedes means before k. So let us look at all those letters in the alphabet. F, is equal to, okay, what are the letters? We start with A, of course, A, but is an vowel. Okay, vowel cannot be written, so leave it. A, E, I, O, U are vowels, so leave them. A, no. B, yes. B, consonant before K, yes. C, yes. D, of course. D, E, can't write because it's a vowel. Okay, then E gone. F, yes. G, correct. H, right. I is a vowel, so I cannot be written. I, J, yes, J is a consonant, so J. Then K, no, you can't write K. They have told which precedes K, not up to K or till K. If they say until or up to K, then you could have written K, but precedes before K. It's J. Let's stop at that. That's the answer.